Last time we called it segment chord theorem. It's the same thing as this intersecting chord theorem that we have here. And by definition, it's when two chords intersect each other inside a circle, the blank of their segments are equal. What do you think goes in that blank? The what? Not length. The product. Okay, because you're multiplying those segments together. Okay? So AP times PD would equal what? CP times BP. Okay, and it's just part times part equals part times part. Yeah, I said this is part of review.
Oh, okay.
We just called it something different. We called it segment chord theorem instead of intersecting chord theorem. So we should be able to do these three examples, okay? For example 1, I'll just number them. Example 1, how do I figure out x? 3x equals 24, or 4 times 6. So 3x equals 24, x equals 8. Okay, remember that their lengths aren't necessarily equal. The product of their segments are equal. Because notice when I plug in 8, 8 plus 3 is 11, 6 plus 4 is 10. Okay, so their chords aren't necessarily equal, just the product of the segments are. Okay, example 2, how do I solve for y? 4y equals 30, so y equals 7.5. And number 3, x squared equals 36, so x equals. Any questions on that? That should have been review. Okay. The next 3 things, I want you to worry less about the name of it and more about like what it looks like so that you know what rule you're applying. Okay? However, the next part is called a secant segment theorem, and it says that if two secants intersect in the exterior of a circle, then the products of their secant segment and their external segment are equal. Okay, so in relation to this picture to the right, what this is saying is that W times W plus X equals Y times Y plus Z. So it's that external piece times the whole thing equals the external piece times the whole thing. Okay, so that's how you get the W times W plus X equals Y times Y plus Z. So it's always the outside times the whole. Okay, and that's what we're going to put into words. It is the outside part times the whole equals outside part times whole. Okay, does everybody see how that? Okay. So, looking at our first example, example 1, how would I set up my equation? Huh? 4 times x plus 4 equals, yes, 5 times 10. Does everybody see how we got that? So you take that outside piece times the whole, outside piece times the whole. So you have 4x plus 16 equals 50, and solve. So if I subtract 16 from both sides, I get 4x equals what? 34? Divide by 4, and x equals what? 8.5. Okay, and you can always go in and make sure that you've done it correctly. So if x is 8.5, then 4 times 12.5 should equal 5 times 10. 4 times 12.5, 50? Yes, no, maybe? Yes. Questions on number 1? Okay, try number 2 on your own. Set it up and solve. Try number 2 on your own. Once you're done with 2, try 3. I'm going to come around and check what you have. Okay, most of you are wrapping up the last one. When I went around, everybody had them correct so far. For number 2, how did you set it up? 12 times 18 equals?
8 times 8 plus x.
Very good. And when you solved, you got x equals? 19. Okay, when you set up the third one, what do you get?
6 times 15 is equal to 5 times 5 plus x.
Okay, and when you solved, you got?
13.
13. I can tell you that the biggest mistake people are going to make is just multiplying the two numbers together. Do not forget that you have to add. It's part times whole. Okay, part times whole. Any questions on the secant segment theorem? Like I said, worry less about the name of it and more how to identify which equation you're using or which formula you're using. Okay, the next one is a secant tangent theorem. Okay, a secant tangent theorem. Okay, and it states that if a tangent and a secant intersect in the exterior of a circle, then the product of the secant segment and the external secant segment is equal to the square of the tangent segment. Okay, so it already started our equation for us. Okay, it's still the same thing when dealing with that secant on xy. It's x times x plus y equals the square of the tangent segment. So how do you think we're writing that? z squared, or z times z. Okay, so it's outside part times whole equals outside part squared. Okay, so anytime you have secants, you're always taking the outside part times the whole. Outside part times the whole. Okay? So, for example number 1, how would I set this up? 1 times 4 equals x squared. So you have 4 equals x squared and x equals 2. Okay, try example 2 and 3. I'm going to come around again. Actually, just do 2. You can attempt 3, but 3 is going to have a quadratic, so we can do that one together if you want. Okay, how do you guys set up number 2? 5 times x plus 5 equals 7 squared, so 5x plus 25 equals 49. And then you get 5x equals 24, x equals 4.8. Very good. Okay, for number 3, it's just a little bit different because we're going to end up with a quadratic. How do we set it up? Very good. Okay, when we distribute, get x squared plus 10x equals 144. Anytime you have a quadratic, the first thing you want to do is what? Set it equal to 0. Okay, so x squared plus 10x minus 144 is going to equal 0. Okay, now I'm looking for my factors of negative 144 that are going to add and give me 10. 18 and 8? Okay, so which one's going to be negative? Very good. X minus 8, x plus 18. Leaving x to equal what? 8 or negative 18. Okay, anytime you have 2 answers, you want to make sure that you're not going to have a negative segment. Okay, so do both of these work? No. Which is the only one that works? X equals 8. Any questions on 3 or the secant tangent theorem, period? No? Okay. The next one is the perpendicular tangent theorem. Okay, we called this a tangent chord theorem. It's the same thing. Okay, the important thing here is to know that your tangents are always perpendicular. Okay, so they form that 90-degree angle. So any tangent line to a circle is perpendicular to the radius drawn to the point of tangency. Okay, so from the radius to the point of tangency is always, always, always going to give you a right angle. Okay, I want to make this picture into a problem because it's important. So if I were to draw a secant to connect O and P, okay, I'm going to label this C, sure. So from C to P is going to be 10 meters. And from R to P is 20 meters. And I want to know what is the radius measure. So what is the measure of the radius? How do you suppose I could go about solving this problem?
We don't have to
We can't use trig because we don't have any of the acute angles. Which measurement represents the radius? OC and OR. Are they the same measure?
Yes.
So what could I put there? So now how could I go about solving for x? X plus 10 squared equals 20 squared plus x squared. Do you guys see this right triangle here? Okay, so your hypotenuse is x plus 10, and your legs are x and 20. Okay, very important that when you do x plus 10 squared, it is not just x squared plus 100. Okay, x plus 10 squared is x plus 10 times x plus 10 equals 20 squared, which is what? 400 plus x squared. Okay, when I FOIL this, x plus 10 squared, what am I going to get? X squared plus 20x plus 100. Remember, you have to do first times first, first times last, and then last times first, last times last. Okay, don't forget your FOILing skills from Algebra 1. Okay, so then you have equals 400 plus x squared. Okay, your x squareds, if I subtract x squared from both sides, those just cancel. And I'm left with 20x plus 100 equals 400. So I'm going to subtract 100 from both sides, and I have 20x equals 300, making x what? Okay, this is a very important question. So if you have questions, please ask now. You will see this again in your near future. Yes?
How do you set up the first one with the square?
Pythagorean theorem. So you had your hypotenuse, which was PO, and then these two are your legs because of that point of tangency making that right angle. Any other questions? Are we sure? So if I have x plus 10 times x plus 10, I'm going to take first times first, which is x squared, then first times last, which is x plus x times 10, which is 10x, then last times first, and then last times last. And that's when you get the x squared plus 20x plus 100. Yes, Cliff?
Writing that equation, can you show me where you like
Pulled all what stuff?
Like, I don't get where x plus x squared came from. I thought it would go like 10 times
10 times.
I'm going.
Oh, because you're trying to use the other theorems, but we're using Pythagorean theorem, where a squared plus b squared equals c squared.
Oh, okay.
So the hypotenuse squared equals the sum of the legs squared. So that's where that 10 plus x squared, which is c, equals our two legs. Any other questions? Those are all really good questions. Are we sure? It's important. Okay. Turn the page then. Okay, the next one is the tangent segment theorem. Okay, if two segments are tangent to a circle from the same point outside of the circle, then those two segments are congruent. Okay, so if you have two segments that are tangent, then the portion, so from P to K, is going to be congruent to PJ. And there's not a problem associated with this. You just have to be able to identify that. Okay? So, if two tangents intersect at a common point outside of your circle, then the two segments that they create are congruent. Got that? Okay. Alright, so we are going to start doing some of these. Okay? I am going to just call you guys up one at a time to do some of these. Yay!